Good morning, students. Here we start with the sixth problem of practice set 2.1. The problem goes as such. Find the side and the perimeter of the square whose diagonal is 10 centimeter. This is given to us. Okay. So this is what is the square given to us, in which we have been given the diagonal that is 10 centimeter, right? And we are supposed to find the length of the side and the perimeter. Length of the side and perimeter means sum of all four sides we have to find out. Okay. So here we start with the solution. Now to calculate the length of the side, what we have to do is we have to use the Pythagoras theorem to find the length of one of the side. Okay, now it is a square, so we know that all the sides of the squares are equal, right? AB is equal to BC is equal to CD is equal to DA, right? We will suppose that BC is equal to X. Okay, so here let the quadrilateral ABCD be the square. Okay. Now here AC is given to us as 10 centimeter. Length of AC is given to us as 10 centimeter. Okay. Now we will suppose that let the length of side of square be X centimeter. So here AB is equal to BC is equal to X centimeter. As it is a square, so length of AB will also be equal to X. Now we will consider only triangle ABC. Right? Now which is this triangle ABC over here? Triangle ABC is a right angle triangle. Okay? So in triangle ABC, angle ABC is equal to 90 degree, right? So which theorem we have to apply now? We have to apply Pythagoras theorem. Therefore, by Pythagoras theorem, AC square. Now this AC will be the hypotenuse. Okay. So it is AC square is equal to AB square plus BC square. Now substitute the values. When we substitute the values, it will be 10 square equal to X square plus X square. Okay. Now here X plus X becomes 2X and square of 10 is 100. Okay, square of 10 is 100 and square of means X square plus X square will turn out to be, it will be added. So it will be 2X square. Okay, now what will be X square then? X square will be equal to 100 upon 2. That is equal to X square is equal to 50. Okay, so what is X? X is equal to under root 25 into 2, that is equal to 5 under root 2. Right? So therefore length of AB is equal to BC is equal to 5 under root 2 centimeter. Okay. Now the length of, the perimeter we have to find out now. So perimeter of square equal to How many sides are there? 4. 4 into side. So that is equal to 4 into 5 under root 2. That is equal to 20 under root 2 centimeter. Okay. So what will be my final answer? My final answer is side of square is 5 under root 2 centimeter and perimeter of square is 20 under root 2 centimeter. Okay. Question number 7 now. In figure, angle DFE is 90 degree. FG is perpendicular to ED. We have been given the length of GD as 8, FG as 12. We are supposed to calculate EG and we are supposed to calculate FD and EF. Okay. So here as FG is perpendicular to ED, right? So we can calculate FD by using the Pythagoras theorem. Okay. Second part, that is GE we have to calculate. So here we can apply second part. So here for GE we can apply geometric mean over here. What is geometric mean? That is FG square is equal to GD into GE. So two values are with us. Third value we can calculate. And the last part, that is EF. So either you apply, yes, you have to apply Pythagoras theorem only. Is it clear? So here we start. Very first thing we will find out length of FD. Okay. So here what is given to us? Solution. Okay. In triangle GDF, comma, angle FGD equal to 90 degree. FGD equal to 90 degree as it is perpendicular given to us, right? So by Pythagoras theorem, what will be the length of DF? So it is DF square is equal to FG square plus GD square. Okay. Now here I'll substitute the value. FG is 12 square plus 8 square. So it is 144 plus 64. So that is equal to 208. Right? That is equal to 208. So DF square equal to 208. So what is DF? Square root of 208. So that is equal to under root 16 into 13. So that will be equal to 4 under root 13. What we have done? By taking square root on both sides. Right? So DF we have calculated. Therefore, length of DF is equal to 4 under root 3. Now what we have to calculate? Now we will be calculating GE. So what I said, for this you have to apply geometric mean. So second part now. In second part, that is in triangle DFE Okay, in triangle DFE, FG square is equal to GD into GE, okay, by theorem of geometric mean, right? By theorem of geometric mean. So here, substitute the values. So here it will be 12 square equal to GD is 8 into GE. So GE is equal to 144 upon 8. So EG is equal to, now when I divide this, my answer turns out to be 18, right? What do I get? 18. Is it clear? So this is the second part that we have done. Now the third part. What is third part? In third part, we have to find out length of EF, right? So here, now for side EF, we will go with the triangle EGF. So in triangle EGF, angle EGF equal to 90 degree. Therefore, EF square is equal to FG square plus GE square. Now FG is given to us as 12. So square of 12 plus GE is calculated by us, that is 18 square. Okay. So that will be equal to square of 12 is 144 plus square of 18 is 324. So that is equal to 468. Now this is EF square. So what will be EF? EF is equal to square root of this now. So it will be equal to 6 under root 30. Okay. So what we have calculated? We have calculated length of EG. Length of EG equal to 18. First one. Okay. Second one, we have calculated length of FD, that is equal to 4 under root 13. And the third one that we have done, that is length of EF, that is equal to 6 under root 13. I hope I am clear. Now we move on to the next problem. Now 8th problem we are doing. Here, find the diagonal of the rectangle whose length is 35 centimeter and breadth is 12 centimeter. So length is given to us as 35 centimeter and breadth is given to us as 12 centimeter. We are supposed to find the length of the diagonal. So what we are going to apply over here? We are going to apply Pythagoras theorem. So we start with the solution over here. Okay. Now, what is given to us? Let quadrilateral ABCD be the given rectangle. Okay. BC is given to us as 35 centimeter. And DC is given to us as 12 centimeter. So we have to just concentrate on this particular part of the triangle, this part of the triangle, okay? Because we have to apply Pythagoras theorem to get the length of BD, okay? So in triangle in triangle BCD, okay, angle BCD equal to 90 degree. Therefore, BD square is equal to BC square plus DC square by Pythagoras theorem. Okay, by Pythagoras theorem. Now what else? Here, what we are going to do? We are going to substitute the values now. So the very first one, BC is 35. So here it will be 35 square plus DC is 12. So here it is 12 square. Now square of 35 is 1225 plus square of 12 is 144. When I add this, what do I get? I get 1369. Now this is BD square. Now what we want? We want BD. So what will be the length of BD? We have to take square root of it. So square root of 1369 is 37 centimeter. Right? What it is? 37 centimeter. What we have done? We have taken by taking square root on both sides. Right? So what is my answer? The diagonal of rectangle is 37 centimeter. I hope I am clear. 37 centimeter. Okay. Now, ninth problem, very important problem. Okay. What is given to us? In the figure, M is the midpoint of RQ. Okay. What else is given? Angle PRQ is 90 degree. What we have to prove? We have to prove that PQ square is equal to 4 times PM square plus 3 times PR square. Okay, PR square. Right? This we have to prove. I'll repeat one more time. PQ square is equal to 4 times PM square minus 3 times PR square. Sorry, first I said plus. It is minus 3 times PR square. Okay, so let's begin. So in triangle PQR, now here it is proof. So we are not going to write solution. We have to write proof over here. Okay, so what is which is the triangle given over here? In triangle PRQ. Okay, angle PRQ is equal to 90 degree, right? Angle PRQ is equal to 90 degree. So what you are going to apply? You are going to apply Pythagoras theorem. So it will be PQ square is equal to PR square plus RQ square. Okay. So by Pythagoras theorem, PQ will be the hypotenuse as R is 90 degree. The opposite side is hypotenuse. So here it will be PQ square equal to PR square plus QR square. This is my equation number 1. Right? Now, we will consider another triangle over here. Now, which is the another triangle? The another triangle is PRM. Okay. So, in triangle PRM now. Okay. What will be the length of PM square now? That is equal to PR square plus RM square. Okay. PR square plus RM square, right? This PR square plus RM square. Now this RM can be written as half of RQ, right? Why? Because M is the midpoint of RQ. It is dividing RQ into two equal parts. So RM can be written as half of RQ. Okay. So what I have to write? RM now is equal to half of RQ. Why? Because M is midpoint of segment RQ, right? So in place of RM, I'll be substituting half of RQ. So what that equation turns out to be, this is my equation number 2. Okay, now this equation turns out to be PM square as it is equal to PR square plus in place of RM what I have to substitute? Half of RQ. So it will be half of RQ whole square. So that is equal to PR square plus 1 upon 4 RQ square. This is PM square. Now what I have to do with this 4? I'll be multiplying the whole equation with 4. So what I'll get? I'll get 4 times PM square. Okay. 4 times PM square is equal to 4 times PR square plus RQ square. Right? Plus RQ square. What I have done? I have multiplied equation by 4. Okay. Now here, what I have to do? I have to arrange now. What I have to do? I have to arrange. Okay. So here, 4PR can be written as 3PR and 1 PR will come out of it. Okay. So here it is 3PR square plus PR square plus RQ square. Now what is this PR square plus RQ square? What it is? Okay, it is equal to PQ square. Right? So here 4 PM square is equal to 3 PR square plus this turns out to be PQ square, right? This is from equation 1, right? So what do I want? I want PQ square. This PR I'll take to the other side. It is 4 times PM square minus 3 times PR square. I hope you are with your equation. Yes? Are you with your equation? What was to be proven? It was PQ square is equal to 4 times PM square minus 3 times PR square. And we have reached to the equation 4 times PM square minus 3 times PR square. I hope it is clear. Now we move on to the next problem. We are on the last problem of this exercise. Okay. Very interesting problem, right? Though the length is very big, but it is very easy. Once you understand, you will be able to solve. Okay. Now what is given to us? Walls of 2 buildings are on either side. Naturally, it will be on the either side of the 2 streets. Okay. These are 2 buildings and AB and ED are the walls of these respective building. Right. Now BD is the street between the 2 buildings. Fine. Now there is one ladder being laid on the building, one at a time. So AC is the ladder for the building with the wall AB and CE is the ladder for the building with the wall ED. Right? Now this wall will be perpendicular to the street as it is standing straight. So here the angle so formed is 90 degree. Right? And again this wall will also be the straight to the base, that is the street. So here the angle so formed is 90 degree. Fine. Now the length of the ladder is given to us as 5.8 meter. Okay. Once it is laid as AC and the other one is EC, right? So length of AC will be equal to length of CE, that is equal to 5.8 meter. Okay. What we have to calculate? We have to calculate the length of this street. Okay. So here one of the triangle is forming. Which triangle it is? Right angle triangle. So with the help of Pythagoras theorem, we will calculate BC. Then here again the right angle is forming. So your CD will be calculated with the help of Pythagoras theorem. Correct. Then we have BC and CD. So what we'll be doing with that? We'll be adding both the lengths to get the length of BD, that is the length of the street. Such a easy problem it is. In 3 steps we have to do. So first we'll calculate the length of BC. Now here AC is equal to CE, equal to 5.8 meter, right? Now here first we'll consider triangle ABC. So in triangle ABC, angle ABC is equal to 90 degree. Therefore, AC square is equal to AB square plus BC square. Right? Substitute the values. So, AC is given to us as 5.8 whole square equal to AB is given to us as 4. So, square of that plus BC square. So what will be BC square? That will be equal to 5.8 square minus 4 square. Okay. So here this is equal to, now 5.8 whole square is equal to 33.64 and minus square of 4 is 16. Now it is 16.00, don't subtract it from 64. We have to subtract it from 33. So this is equal to 4 point, so this is equal to 17.64. This is BC square. So this is BC square, that is equal to 5.8 square minus 4 square. That is 33.64 minus 16.00. So the subtraction is 17.64. Now BC square is 17.64. So what will be BC? BC is equal to 4.2 meter. Right? What is BC? It is 4.2 meter. Now this is the length of BC. This length. That is 4.2 meter. Fine. Now we have to consider another triangle now. Which is the another triangle over here? In triangle EDC. Angle EDC equal to 90 degree. Therefore, EC square is equal to ED square plus DC square. EC is 5.8 whole square equal to ED is given to us as 4.2 whole square plus DC square. Okay. So here the value of 5.8, first DC will take the side. So DC square is equal to 5.8 whole square minus 4.2 whole square. Right. So value of 5.8 is 3.64 minus 4.2 is 17.64. When I subtract this, the value turns out to be 16, right? So DC square is equal to 16. So what will be DC then? So what will be DC? DC is equal to 4 meter, right? DC is 4 meter. Now I have DC, I have BC. Okay, I'll just put a box over there so that it is clear to us. Now what we have to find out? We have to find out BD. That is equal to BC plus CD. So that is equal to, BC is what? 4.2 plus 4. That will be equal to 8.2 meter. Okay. So width of the street is equal to 8.2 meter. So here we end up with the first exercise. Thank you.